test. Oh, yeah.
All right. Let's get going here. So Jay Johnson is the Chief Technology Officer at DER Security Corp. Jay is coordinating the construction of cybersecurity protection, detection, and response technologies for EV chargers, renewable energy installations, and energy storage systems. Previously, Jay was a distinguished member of technical staff at Sandia National Laboratories, where he led research projects totaling $25 million in the areas of power system control, optimization, and security. Jay has authored more than 150 academic papers, 10 patents, and was interviewed for Wired, Forbes, NPR, and several other media outlets on his EV charging cybersecurity research. Excellent, man. Take it away. Thank you for being here.
Yeah, thanks everybody. You made it back from the lobby and from the coffee break, so I appreciate that. There's been a lot of talk about kind of the IT areas of cybersecurity at this conference so far. How many people work in OT, operational technology, the things that run gensets and power systems and water and wastewater and those types of things? So a little there, okay, some here. Yeah, so this talk is all about that. It's all about power systems. It's all about the things that actually run our society, the critical infrastructure. And so I'll be talking about vulnerabilities and defenses for distributed energy. Distributed energy, or distributed energy resources, is the DER in our title of our company. That's your like battery systems, and it's everything from Tesla's power walls in your garage all the way up to these mega packs and bigger systems that run our power grid now. Like the amount of battery systems going into the power system right now, and especially co-located with data centers and the massive boom there, is tremendous. So there's a ton of development in that space. So as was mentioned previously, my background is working for the US government at Sandia National Laboratories. I did a lot of development of the communication protocols used for these DER devices. So Sunspec, Modbus, DMV3, IEEE 2030.5, protocols that you probably don't run across in the IT space, right? These are the things that actually tell you telemetry from this equipment and move control signals back down to the endpoints. I had the honor of leading red team assessments on military microgrids, on a bunch of EV chargers, level 3 chargers. Those are big DC ones that sit like this out by Walmart. And I did a lot of power system modeling as well. So this talk is going to be split into a few different chunks. The first little bit is going to be kind of a threat briefing to talk about some of the attacks and vulnerabilities on solar infrastructure and electric vehicle charging. You're all going to get to be the first people in the world to hear about a new CVE that I'm finally releasing after a couple of years of sitting on today. And then I'll talk about OCPP, or Open Charge Point Protocol attacks, and that's the communication protocol that's used for a lot of the EV charging networks. And then lastly, talk briefly about some of the cyber defenses. So how many people here have heard about Volt Typhoon? Maybe you've heard about Salt Typhoon, so the Chinese threat actor working in the telco space and sucking up a lot of private information. Well, Volt Typhoon is another APT out of China that is really embedding themselves persistently in US critical infrastructure right now. And there's a fantastic podcast by Nicole Horwath that I strongly recommend you take a listen to. And it goes into the details of how they're getting into these systems, and they're using living off the land techniques and methods to basically sit on these systems, and they will just check their credentials every 90 days or so to make sure they still have access, and then log out. And it's extremely difficult to pick that up because there's no indicators of compromise. There's nothing there, right? And so, what do we do about that is the big question. So a few different ways, a few different attack vectors to penetrate DER systems. I'll briefly touch on these. Kind of over on the left side here, you can see the head-end systems. So this is your cloud infrastructure and your management systems. So the vast majority of PV systems and EV charging networks are cloud deployed. They've got your normal, SaaS providers out there that provide these services. And so if you lose your access to that infrastructure, you have insider threats, then you can control these systems in bulk. There's other APIs and apps, mobile apps that have been the source of a lot of vehicle issues over the last decade or so, I would say. Similar things here, where there's vulnerabilities being reported nearly every 6 months or so in this space, lots of them. Take a look at some of the Forescout research that's recently come out. And then, unfortunately, a lot of these protocols are unencrypted. And so man-in-the-middle attacks and things of that nature, that replay attacks can happen once you're on that OT network. And then at the device level, which is what I'll be talking about here, there's a lot of interfaces. So if you tear apart one of these big DC chargers, there's USB ports, there's serial interfaces, there's internal networking, right, because there's multiple boards. And so if you can tap into the control signals there, you can actually manipulate the operations. You can turn off the cooling loop for the charging cable. You can shut down certain power supplies that exist in the back end. And so there's a lot of vulnerabilities associated with that. A couple of months ago, we published a white paper called Solar Energy Cyber Attacks and Vulnerabilities. And in that, we talked about this history of different vulnerabilities in this space. And as you can see, it has been increasing. We'll see where 2025 ends up at the end of the year. But there's been a lot more publicity in this space. It doesn't mean the systems are getting worse, right? It means more people are paying attention and talking about it and looking into this. So that's great. And so I wanna briefly speak about these different attacks that have occurred over the last 5 years or so. The first one is in March 5th, 2019, there was a DDoS attack on a organization called S-Power, and they manage wind and solar assets in California, Utah, and Wyoming. And there was an outage because there's an unpatched Cisco router there that was being DDoSed. And this is actually the first cyber attack on the U.S. power system in the history of the U.S. power system, where they lost visibility. They eventually patched that system and got it back up online. The Palo Alto Networks Unit 42 has been reporting that some of these kind of gateway devices that they basically translate one protocol to another protocol down to the endpoint device. They've been used through different code injection techniques to be compromised into the Mirai botnet. And then in 2023, there was some installer level credentials that were used to modify some grid support functionality inside these devices in Romania. 2024, 800, again, remote monitoring and kind of gateway devices that pick up on the power system data from these PV systems. These are actually mostly in Japan. Were compromised and used to fraudulently route bank transfers. So it's believed that there were nation-state actors that were basically routing fraudulent bank transfers through this botnet in order to hide their tracks. 2024, a pro-Russian hacktivist group called Just Evil targeted Lithuanian solar monitoring solutions, and they were able to, it's believed, just get regular credentials, either through brute force or some other social engineering campaign to get into these systems where they can control these things. What's interesting about this is it was actually tied to some government facilities, schools and medical facilities. And then most recently, the FBI and NSA have reported that China-linked actors have been compromising solar devices. So pretty recently, a Greek researcher, this gentleman, Stikis, discovered that there are 6 different solar platforms. These are cloud platforms that he was able, through various different means, gain super admin access to. And what that means is he could see the full visibility of all of the PV systems attached to these back-end systems. And so you can see here it's almost 220,000 devices that he had access to. And with that access, he could perform remote firmware updates. He had a backdoor into these networks, and he could potentially just brick the devices entirely, which is a huge risk to the power system, right? Because in a lot of cases, these devices are a significant amount of generation to the point that a disruption there will cause the grid operators some real challenges in maintaining that balance between generation and load. And then more recently, Reuters came out with a report saying that there are some undisclosed communication devices inside these commercial and industrial and utility scale inverters that would allow Chinese access to the equipment. Over here you can see there was an interesting case where Daiei, which had a financial agreement with Solarc to basically maintain the back ends. They decided to brick, no longer allow the devices to operate in the US, all the inverters that had been installed in the US without explicit permission to have connections to their back end. And so what's frightening about this is we have some numbers from Europe in particular that controlling just 3 to 4 gigawatts of energy there could lead to disruptions with like somewhere around 10 gigawatts of control, leading to a blackout. And the reporting out of Solar Power Europe most recently has indicated that there's somewhere on the order of 200 gigawatts of solar capacity there, most of it coming from China, and several manufacturers have more than that 10 gigawatt limit, right? So at that point, you're at the tripping point. So similar to what we saw in Spain and Portugal for the Iberian blackout, that can happen here. So let's switch over to the EV charging cybersecurity. In this case, there are several different interfaces to these devices. You've got your credentialing system. So think of like public chargers. Walk up, you have an RFID tag or some other, credit card swipe, or maybe your phone has an app on it. You connect to that. You say, I am who I am, and then you're able to couple into your vehicle and start the charging session. There's also back-end communications that we've talked about before up here, and then maintenance terminals as well. And so these are the 4 interfaces that can be potentially compromised and have been in the past. So let's talk about each of these. The charging cables themselves, there's actually communications that run between the vehicle and the charger. So the vehicle is communicating, hey, I'm at this state of charge, I have this allowable amperage that I can take from the charging infrastructure. And if you hijack that communications or tap into it, there's some additional functionality there that most people haven't looked at. So you can actually SSH from a charging cable into the EVSE, the electric vehicle supply equipment. You can actually, very recently here, there was a Tesla charger that was compromised because there was a firmware update capability over that charger, or over that charging cable, where you could essentially, if you plugged in from a Tesla that was internet connected, it would push updated firmware to the device. And so there was a phone-to-own competition where they discovered this communication pathway, and they were able to compromise that in a way that they could root the device. And then out of the University of Oxford, there's been a ton of work that's really fantastic about compromising the charging sessions using a side channel attack where you basically broadcast RF signals to that and couple into that charging cable so that the communication link is broken. And without the communication link, it's no longer able to communicate. And so what you see is these stop charging messages when that occurs. And so there's their setup in the boot, since they're in England. I don't know if this audio will come through, but I'll show you. Yeah. Well, all All right, so user interfaces, there's a few different things here. You can clone the RFID tags. There's a lot of talk right now about fraud in this area because these RFID tags can be manipulated or brute forced in certain ways. Here's an example of a charger from Electrify America where they accidentally left a TeamViewer session on, and they were able to log in with their smartphone and interact with the equipment. So it's a Windows machine, which isn't too common, but Windows machine, and they're able to navigate to the internet using their phone here, just accidentally left this session on. So inside these devices, there's tons of interfaces, right? There's all this communication and capabilities there. I'll point out one example here. So some research that came from Pentest Partners. What they did is they found inside this EO box, and I've actually found other devices that have this, where there's just a Raspberry Pi sitting there, right? Raspberry Pi is great, except that it doesn't include any secure boot. There's no encrypted drive. It's just an SD card that holds everything. So you just take that SD card, plug it in your laptop, add your credentials, plug it back in, log in, SSH in. You can basically modify the entire operating system. So that's an issue if you want to maintain any source control over your software or control over the communications from these systems. And here's a supply chain attack where in Russia, at the time of the beginning of the Ukraine-Russia conflict, what happened is the Ukrainians figured out they had supplied some equipment to Russia for this EV charger, and they said, well, we have access to this. I don't know if it was legitimate or a true backdoor or what, but they were able to push firmware or an update to these chargers to basically prevent them from charging. So a traditional supply chain attack. And so it basically prevented the chargers that ran on the M11 or M1 corridor between Moscow and St. Petersburg from operating and displaying, Putin is a dickhead and glory to Ukraine. So here's some work that I recently, well, not so recently, did, but started about a couple years ago, got halfway through, dropped it, and picked it up for this session. So congratulations, you get to hear the latest and greatest in this space. So we've got a new CVE that I'm announcing here. It's for this guy right here, this juice box. It's an Enel X-Way device, level 2 charger, and essentially the vulnerability associated with it is almost trivial. Everybody over there at the capture the flag game could do the same thing, right? So you connect this to your Wi-Fi network, and from that there is access to operating system commands that allow you to extract PII, change certain settings, and manipulate the file system. And so let's take a look at what this actually is. There's this nice Wi-Fi module that is provided by Silicon Labs inside this device. And with that comes an API where you can run all these commands. So many interesting commands. Look at all this stuff. You can do HTTP uploads, factory resets, ping, so potential DOS or DDoS attacks. You can format the flash. You can do a lot of different things. And for that reason, if we look over here, you can upload and download files. You can read and modify the Wi-Fi password. You can reboot the device. Luckily, there's only about 20 of these things out there on the internet, so that's good, but this is a severe vulnerability with this equipment. So this is what it looks like. Basically, you just netcat into this thing on port 2000. You can get all the parameters, doing a get all. Here's a throwback to my Albuquerque people. Here's your Wi-Fi password. I'm the one who knocks. And the Saul Goodman Wi-Fi is right there in plain text for anybody to read. So if you can find them on the internet, you can get the Wi-Fi password for these. And so there's a lot of CWEs associated with this, as you can see here. Probably should vet some of these with CISA or others, but pretty fascinating. One of the things that is on this device, if you look at the operating system, is a PEM file. So X509 certificate. And that X509 certificate is for a DNS record called evconnect.com. And evconnect.com is, you know, this is kind of like a third-party back-end management system. And so that, I believe, they never actually fully implemented this. This company has actually gone bankrupt, or they got rid of the assets, which I'll talk about here in a minute. But I think they were on the verge of using this as their OCPP, Open Charge Point Protocol, back-end system. And so there's actually kind of this other market for that, where they can hook up to these other networks and then communicate that information to them, and then they handle the management of it, whereas the physical devices are manufactured by a different company. And so what does this give you? If you, in this case, you know, credentials were expired, I don't think they fully implemented it, but if you could do this for another charger, what would you be able to do? Well, there's a lot of things. So if you're at the head end system and you compromise something, like Stykus did, or if you're down here at the EVSE level, like vehicle supply equipment level, there are different things that you can do, and you can try to compromise the other direction, right? So from up here, you have the ability to push remote stop transactions. You can stop charging sessions. You could change the tariff rates. You can make it really expensive or make it all free. You can do firmware updates, things like that. From this side of the system, going that direction, you can do your code injection attacks. You can try to compromise the head-end system to compromise the entire fleet. You can manipulate the measurement data. So, I didn't really charge that much, don't bill me, you know. Or manipulate some of the transaction events so that it doesn't look like you actually need to be billed or you did anything. You can modify serial numbers or vendors or other things. So this one's kind of interesting because you can manipulate all of the equipment there, right, to basically ruin the database. So you're just like pushing garbage into their database, and so now they don't know what to trust. You could iterate over the serial numbers and models, so cause a bunch of issues associated with that. All right, so we've got a timeline here of what happened basically back in 2023, reported this to Vince and then notified the company of the issue. Didn't get a response. As I said, they've kind of closed doors, but they suggested I go public, and I eventually did today. So this is the timeline of that. Again, these are stranded assets that I believe most recently this Vulti group has actually tried to help out the customers of these equipment by providing the back end. If you want to protect your equipment, you can actually set a password for the kind of remote terminal interface, which is not there by default, or you can disable it with these commands. And there's a lot of other work that somebody else can pick up on with this if they're interested to reverse the app or the kernel or try to get that information and modify it. And so I realize I'm closing in on my time here, so I'll just briefly talk a little bit about some of the defenses and then hopefully get a few questions. So the thing I was talking about with Volt Typhoon is that they kind of skip over the cyber kill chain, right? So normally you're doing all this recon and weaponizing stuff and then doing this fancy stuff where you're delivering these payloads that get executed and then indicators of compromise show up along this chain. But what they're doing is they've got valid credentials, they log in like a normal user, probably using a normal user's account, and then just go straight to deploy, right? Just to manipulate the OT system however they choose. And so our company, DER Security, is focused on the cyber physical layer down here, these actions on objectives, to actually look at the physical impact of what's going on and detect it at that level. So we provide a network intrusion detection system that does the normal stuff, network analysis, using Zeek, Snort, Surcata, those types of things. But we also extract the information in those protocols, convert it to physical meaning, voltage, frequency, power, and then combine these two things to say, hey, does this stuff make sense? Is it valid? Are there anomalies here that would indicate that there's something going on at the power system level that's actually preventing this from working correctly? And so as an example of that, here is a autonomous grid support function called VoltVar, where at low grid voltage, you're injecting reactive power, and at high grid voltage, you're absorbing reactive power. And so normally you follow this curve, because that's grid supporting, grid helping. But if you flip a sign in that command, you actually get grid damaging. You're injecting reactive power at high grid voltage, which pushes the power system into an unstable state. Interestingly enough, in the Iberian blackout, there was a solar plant that had been misprogrammed in this way, where when there was a voltage perturbation, it did the exact opposite of what it was supposed to, which actually exacerbated the problem and caused more issues for the grid operators there. And so this type of thing can happen, accidental or not, and our adversaries are paying attention to that and causing, well, pre-planning for these types of things. We could talk a lot about that. All right, briefly, the response characteristics for different things is very important. So, hey, you picked up there's an issue, what do you do about it, right? So, in a lot of these local things, what you can do is you can reset those settings, figure out which IP did it, who did it, how they did it, and then isolate that pathway. And so you want to roll back to a known good state. You want to roll back to where it can actually support the grid operations. Similarly, you can roll back firmware if you see a firmware update and all of a sudden the device starts behaving oddly. And then at the kind of head-end system here, you can revert to known good settings. You can also do this analysis. You're gonna do all your normal stuff, blue team stuff, where you're gonna start incident response. You're gonna look at who did it, how they did it, and so forth. But it's very important to, as quickly as possible, bring the OT system back to a known good state and prevent further damage to the operational characteristics of your critical infrastructure. All right, so in conclusion, threat actors are pre-positioning in our energy networks and other critical infrastructure. We've got several vulnerabilities with these PV systems and EV chargers that I talked about today. And then we need some ML-driven, AI-driven capabilities to respond to that and basically restore operations as quickly as possible. So I think we have a few minutes for questions. Yeah?
Does anybody have any questions? This is such an important topic. Like you said, they're planning, they're preparing for C2, right?
So for these chargers, do they not do any like firmware validation or like, well, why are like the most simple basic things that we would do with any other system being completely ignored, right?
Yeah. Well, there's a lot of answers to that question. One, regulation. There is very little regulation in the cybersecurity space, especially in the US. Europe's a little bit better, but here it's the wild, wild west. The second is they get away with it, right? There's such a market push, so much pressure on these companies, and it's so difficult to compete that they take as many shortcuts as they can. And there's actually other research, last point on this, there's other research in this area that was conducted by a researcher called Sebastian. If you go on GitHub, you can see him under Vegan MOSFET is his name, where he's essentially modified the firmware on this equipment for several different devices to have it perform operations that it should not, including tripping the breakers in his own home by switching the IGBT switching signals to that power stage. And so very low level controls. Yeah, sorry.
Okay, I have a question. So you were talking about rolling back to a known good image and things like that. So I'm kind of curious about protection around like the golden image for firmware and things like that. If I was a bad guy and I wanted to have persistence in your infrastructure, I'd try to have my code be persistent in your gold image.
Right.
Like if it were me, that's where I would go. Because that's kind of like your crown jewels, right? You can always knock me down by rolling back, but can you knock me down if I'm in your image already and I'm in your base killing your dudes,
If,
right?
if you're in the build, you're in the build, right?
Right.
Yes, that's a fair point. And so how do we maintain the gold image is a very big challenge. I would say for the parameters, it's a little bit easier. So there are a set of parameters for these energy devices that are required per the US interconnection standard. They come from IEEE 1547. And so that standard says you must be within these ranges of adjustability in order to operate this equipment. And then each jurisdiction, each utility will set those parameters slightly differently, but they're pretty well constrained, right? And so you can hit the parameters pretty well. The firmware images, I agree, it's challenging. How do you know you haven't been compromised in the supply chain? Yes?
So is Alex Adams here? Or are you? There you are. Okay. We're gonna take one more question, and then we're gonna get you swapped over. All right, one more.
On a local level, can you use Wireshark in order to see if there's a vulnerability in that charger that, that model that you showed in your slides?
Can you use Wireshark to see if there's a vulnerability with your charger? In this particular case, I don't think people are regularly communicating on port 2000. It's just a maintenance port, or actually there's kind of a web interface, a local web interface that I believe is using that to populate the web page. And so that's why it's open and exists there. And so I would say that in this particular case, you're not going to see much external traffic in Wireshark to that device. So I would say no, you won't be able to pick that up. I will say a lot of other DER equipment though, if you monitor the traffic there, you're going to see some very strange things and a lot of communications to like Chinese servers and other servers that you would not expect. So it would be interesting to tap into some of those communications and see where they're headed.
Such a great talk. Please give Jay Johnson a round of applause. Thank you all for your questions and